Welcome to the next session. From today, from this series now, we will start learning about the libraries in detail. Libraries are majorly, which contains a huge amount of code which you can use for a specific purpose. For example, we are starting with the NumPy library. It is highly efficient library when it comes to mathematical and the numerical computation. Okay, although the list can also handle these things, because in list we are including 1 2 3 4 or any kind of such values. But when we are talking about, let's say, millions of rows of data, okay, that is where we have to make it in terms of like a matrix or arrays, and that's where the NumPy library comes in, and it has a lot of functions. As you can see over there, these are the things that we will touch upon in our today's session. So let's begin. Okay, so first of all, what exactly is NumPy library all about? Let's talk about it in a brief. So it's like a fundamental library for scientific computation in Python, and is widely used in a lot of fields such as data analysis, machine learning, image processing. And its applied uses are, data analysis and manipulation, mathematical functions, linear algebra operations, time series analysis, risk modeling and simulation, optimization and modeling. Now the point is, how can I import this library within my Python script? Okay, I will type import numpy. But whenever I will be accessing any kind of numpy function, I don't want to type a numpy every single time. So let's give a nickname, import numpy as np. Okay, so this is just the norm that you should follow as np, and then after that we will learn about pandas, so that will be as pd. Okay, so that whenever I am accessing the function of this library, I will just type np dot. Okay, makes sense. Let's begin now. So first of all, let's learn about how to create numpy arrays from a Python list. Dot. Okay, so I am writing now, creating a list. My list is equal to 1 2 3. Simple. The data type of my list is list. Okay, I am now creating the numpy array. So I will type np dot. Now press tab. Now you can see how many features you have within this numpy library, and we will touch upon the relevant one. So I will type numpy dot array. Okay, now I will pass on my list, okay, that I have created. Now if I check my list, you can see now it has been converted into an array. If I check the data type of my list, my numpy array, you can see now it has been converted into a numpy array, and earlier it was a list. Okay, so similarly, not only a single list, you can create the numpy array from the nested list or the list within a list. So like we talk about the combined list. Let's create a variable. This is a list, and within that I will pass the variables as a list. For example, 1 2 3 comma list again, 4 5 6 comma list again, 7 8 9, right? And now I can convert this into a numpy array, and you can see. So see, list within a list has now been converted into an array, and it looks like complete matrix that you guys have studied back in 11th 12th class, I guess, basically in your high school. So we have learned about how to create the numpy arrays from a Python list, whether it is a normal list or the nested list, which we call it list within a list. Now let's learn about some of the built-in methods of numpy, which are very useful. Bu. Okay, so we will first of all talk. So there are four methods we will talk about. That is a range, zeros and ones, linspace, and I. Let's start with the first one, that is a range method. So it is, technically similar to the range that we have covered earlier. So I will type, let's say, numpy dot a range 0 to 11. So it gives me the range from 0 to 11, where the last value will always be excluded. So you can see 0 1 2 3 up to 10. Super simple. Same thing, I can apply the step size within this a range as well. I will type numpy dot a range, let's say 0 to 11 comma 2. So it gives me two jumps, one jump, two jump. So 0, 2, 4, 6, 8, 10. That is my answer. By default, this step size is always 1. Okay, that is why we don't have to type something which is already by default. All right, so if you press shift tab, you can see you have to give the start number, stop number, and the step number, step size. Okay, so that is the information which is written over here, but it's all up to you whether you want to read it or not, but I have already told you enough which is relevant. So this is the first method, that is a range. Next method is zeros and ones. So let's start with zeros. I will type numpy dot zeros. Okay, and I will type just, let's say, 3. So it gives me an array of a single line which contains 3 zeros. Okay, 3 zeros. I can convert it into a matrix in a form of rows into columns. Basically, let's say 2 rows into 5 columns if I want to create. I will type numpy dot zeros and this small bracket. Now within that I will type my big bracket. So I will type, let's say, 2 comma 5. So now it gives me 2 rows and 5 columns, and all of the values are 0 right now. So you see, whenever you are working on a huge amount of data and you are creating kind of a placeholder means when you are creating a space for something, for something that you are going to put it over there later on when you find the answer of that thing. So that is where it is super useful, numpy dot zeros, numpy dot ones. So these are highly efficient over there, but right now we are just trying to learn about the methods, that the functionalities that comes in within this numpy library. So numpy dot zero, 2 rows, 5 columns. So always remember, the first value before the comma is all about rows, the second one is always about columns. This is super useful thing which you should just do remember this thing when we will work upon numpy later on in detail, and the pandas later on. Numpy means the, like, within this session later on. Okay, so numpy dot zero, the same concept with numpy dot ones. I will type, let's say, 4, so it gives me 4 ones. Numpy dot ones, create 5 comma 6. So you see 5 rows and 6 columns of numpy dot ones. Now, the third method is the linear space. We call it lin space. So it helps in creating an equal intervals between a given range. Let's say I will type numpy dot lin space. Okay, and I will type 0 to 10. It means that I will get the answer between 0 to 10, and I am dividing it into 5 separate equal intervals. So you see 1, 2, 3, 4, 5. I get 5 values starting from 0 ending with 10, starting from 0 ending with 10, and these are all equal intervals. You can see that the difference between all of them is 2.5. So 2.5 is the difference. 5 minus 2.5 is 2.5. Over here 2.5, 10 minus 7.5 is 2.5. So that is what I was talking about. Let's say if I will type numpy dot lin space 0 to 10 with 10, so it gives me 10 different so the difference between all of them is 0.111 something. Okay, if you want to see 1 2 3 4 up to 10, so you just type 1 over there, so you can see that 1 2 3 4. So this is, so with the help of this you can create the linear distribution, not the distribution but the linear spacing between your starting point and the ending point. So this is the third method. The last method is the I method. If you remember about the identity matrix that you have done again back in your high school, I will type numpy dot I, and let's say I will give 3. So it gives me the identity matrix. So what is identity matrix? It is simply when on the diagonal in a matrix the values are exactly same, and on the non-diagonal elements the value is always 0. Okay, so it basically means when you multiply, I think, identity matrix with identity matrix, the answer will always be identity matrix. Multiply 1 with 1 is always 1. Okay, so that is about this. So we have covered very small things for built-in methods, that is a range, zeros, ones, linspace, and the I, which is identity. Let's talk about the random library, and within this random library, we will talk about the rand, which is uniform distribution, rand n, which is normal distribution, then rand int, random integer, which we have covered in our previous sessions as well. Okay, so I will type, let's say, um, y is equal to numpy dot random dot rand. Now I will pass on, let's say, 100 values. I am generating 100 values for a uniform distribution, and you guys must know that in case of a uniform distribution, their range is between 0 to 1. So now if I check the value of my y, you can see that the all the values are between 0 to 1. Okay, and if you are aware about the uniform distribution, so how does that uniform distribution work? So it has a range from 0 to 1, if you guys remember, and its mean is or the syntax will be like 0 a to b, right? And its mean is what? A plus b by 2, right? So technically we should get our answer nearby um, 0.5 as my answer, right? So let's say now if I check over there, I will type numpy dot mean of y, and you can see it is around 0.5. It will not be exactly same, because like the more values, let's say if I type 100,000 random variables values, so then it will become much more closer. The higher the sample size, the more you will incline towards your mean. Okay, that is what it's simple logic about the mathematics and statistics. Similarly, if you are aware about the standard deviation, the formula is b minus a divided by square root of 12, right? If you are aware about standard deviation in case of a uniform distribution. So if I try to find the standard deviation of this, so the answer is 0.288. Let's try to calculate in this way. So b minus a, 1 minus 0 is 1. Okay, divided by yeah, square root of 12, which means like 12 to the power 1 by 2, right? Makes sense. Let's make it like this, so you can see the answer is similar, 0.288, 0.288. So that is the uniform distribution. Let's move on and understand about like, yeah, within this. So right now it is just a single array. Okay, I can convert it into, again, rows and columns, same simple thing. Let's say I'm creating a numpy dot random dot rand, and within this I will type 3 comma 4. So 3 rows, 4 columns. Okay, now just one thing to remember over here, when we were using these zeros and ones, so we put this list, we don't call it list, I will call it like the scare brackets, okay, within this, to create my rows and columns. But over here I don't have to type that. So it depends upon, syntax functionalities that is available. Okay, so that is what we are doing. So you see that the random function creates an array, so from a uniform distribution, the values including 0 and excluding 1, that is what it means in a mathematical terms. So you can read about that, how you are using this thing. Okay, although I have covered that much which is relevant. So random 3 rows 4 columns, you can see 3 rows and 4 columns. Now let's move on to the normal distribution. Same concept, numpy dot random dot rand n. N means normal distribution now. So I will type, let's say, 5. So it gives me 5 values between, I think, -3 to +3, if I'm not wrong, the range of normal distribution. Okay, so you can see there are 5 values, and the same concept that you want to create the rows and columns. So just numpy dot random dot rand n, and 5 rows 2 columns, let's say. So 5 rows, 2 columns. You can see the values. -3 to +3. I guess you can check it as well. So the values are between that. Now let's move on to the last one that we have already covered earlier. numpy.random.rand int, that is random integer, 1 comma 100. So it gives me one single value between this. I want, let's say, 20 values, so I can get 20 values as well. Pretty simple. So we have covered about this random library, random module in detail, in which we have covered three methods: rand, rand, and randint. Now let's start with learning about various array attributes and methods, and within that we will talk about the reshape, shape, max, and min. Okay, so I will type, let's say, x is equal to numpy dot random dot rand int. I want the random values between 1 to 100, and I need 10 values. I can see that. Now, technically, this is like a one row and 10 columns, right? So that is 1 cross 10 rows into column, one row and 10 columns, right? I want to reshape it into 2 rows and 5 columns. I can do that because see, the values will remain same. I mean, there are 10 values. So whatever be the row into column combination I have to choose, that should work. Only then it will happen. Okay, so for example, now I will type y is equal to x dot reshape and 2 comma 5. So it gives me the exact this answer into 2 rows and 5 columns. So you can see now 2 rows and 5 columns. So values are same obviously, but if I try to convert it into, let's say, 3 into 3, 3 into 3 means 9 values, which is not correct. So ideally it should give me an error. Let's take a look. X dot reshape again, 3 comma 3. So you can see it gives me an error. Cannot reshape array of the size 10 into 3 into 3, which makes sense, right? Where will the 10th value will go then? So it is highly relevant, when you are working on a huge amount of data and you want it in a specific way, so you can mold it in your own by using this reshape functionality that is available, right? On a similar terms, the shape method has been built, which will tell you about the shape of the array that you have. For example, this y, I will type y dot shape. So you can see it tells me that okay, you have an array which is having 2 rows and 5 columns. It is highly relevant, when you are having, let's say, thousands of rows, thousands of columns. I mean, thousands of rows and few columns. If I talk about from an actuarial perspective, what will be your rows all about? Rows will be all about the policyholder data. The columns will be all about the factors that you are considering for the purpose of pricing or reserving or experience analysis. Make sense? Okay. So we have covered about the reshape, shape. There are two more, that is max, min, and I will type, let's say, so this is my x, the array. If I want to find the maximum value within that, I will just type x dot max. Similarly, x dot min. So these are some small things that is available. Max, min. Okay. Now let's move on with the very important concept within this, that is about the indexing and selection, where we will learn about how to do that in case of a single vector, how to do that in case of a 2D arrays, and how to apply the filtering. Super duper useful. Let's take a look now. I am creating a new array. Okay, numpy dot a range 5 to 20. So it gives me 5, 6, 7, 8 up to 19, right? We all know about that. Pretty simple. Now I want same thing, indexing, that we have covered in our strings list, all these data types earlier. I want to find the value at the fifth element. The answer is 10. We can see 0, 0, 1, 2, 3, 4, 5, right? Same thing, nothing different. Indexing will always be same. And if I want the slicing, you can simply do, let's say, 0, 2, 3. So it gives me answers from 0, 1, 2, 5, 6, 7 as my answer. You can see that. Okay, now let's try to understand one feature which is not available within the list data type but is available within the NumPy. Let's take a look. So I'm creating, let's say, my list, exact similar list. Let's say, let's copy this. I'm creating my list. Pretty simple. Done that. Now, in my list from 0 to 5, values are 5, 6, 7, 8, 9. If I try to convert all these value, I want that all these first 5 values should be 100. If I trigger this, it gives me an error that you cannot do this. You cannot do this. Okay, unless and until you should use like what? The map, the filter, those functions. But in case of NumPy, you can do that. So what was my new array? That is again same thing. Now in this new array, if I apply the slicing, same thing, up to 0 to 5, first 5 values, and I want it to be 100. So now if I check my new array, you can see the first 5 values are 100. Then after that, whatever it was earlier. Pretty same thing. Okay. Not only this, you can obviously do it in a very simple way as well. Let's say if I type 5 to 8 for my, this is my NumPy array, right? And I want these values to be, let's say, 70, 80, 90. And now if I check my new array, you can see 70, 80, 90. Super simple stuff. As we can see that the data has been changed in this original array. I can even create the copy of this array and can make changes over there so that my original array does not change. What am I saying? Let's take a look. I will type, let's say, new array underscore v2 or v1. I'm creating the second version of this array. Same thing that we used to do in case of Excel files in our office, in our daily work. So I am saying that I am creating a new v1 v1 NumPy array by taking the copy of this original array. Pretty simple. I triggered this. Now let's say I am converting all the values of this new v1 array into 100. We all know about that. If you type just colon, it will automatically understand that you are slicing the values from starting to ending. Okay, now if I check my new array v1, so it is all 100. But does it have any impact on my original array? No, it has no impact. So see, that is the beauty of this copy function, that you wanted to just apply some kind of computation on this array, but don't want it to be changed in your original array. Okay, that is how you can do that. Okay, now we have covered about the single vector. Let's understand about the 2D arrays. It will be super duper useful. So let's type 2D arrays. So it is like the foundation for the pandas library as well. I am creating a new array, numpy dot array. Okay, I am creating a list of list 1 2 3 4 5 6 7 8 9. So see, I am creating this numpy array. Okay, then within that I am passing on a list of list, and we have covered it earlier as well over here. You see this thing. So I'm just doing this same thing, nothing different. Trigger this. So that is how my new array looks like. 1 2 3 4 5 6 7 8 9. Pretty simple. Now we all know that if I type the 0, I'm trying to do the indexing over there. Okay, when I type 0, it will give me answer as 1 2 3. I know that. Pretty simple. Now if I ask you that I need the first row and the third column value, which is I just want answer as 3. So what I will do, same thing. So this is 0th element, first element, and second element. So same thing. That is something we have covered earlier as well. Up to this point, nothing new, right? Now there is more cool ways through which you can do that. I will not use the word cool. I will use the more which will be highly used. Okay, what am I saying? Let's take a look. So that is how my new array looks like. Okay, now there is another way through which you can do it using the row into column way. So I will type new array. Okay, square brackets. I need the values from the 0th row. Make sense? So I will type 0, and I need the answer from the third third column, right? So which is technically 0, 1, 2, because the numbering starts from 0 when we talk about the indexing. So I will type 2 over there. You can see my answer 3. Let's repeat what I just did. 0th row, first first row, second row. I need the answer from the 0th row. So I will type 0. Technically, I just want this as my answer. Okay. So this is the number. Tell me the number of column number over here. So this is 0th column, first column, and second column. So that is why 0 comma 2. Before comma, I have to pass on the value of row. After comma, I have to pass on the value for a column. So that is what I did. Okay. So that is not the only way. Let's say if I type new array, and I will not pass on, let's say, the column number. I will just pass on the row. I am saying that I need the first two rows as my answer. So it means 0, 2, 2, because 0, 1, and 2. And we all know that the last value is excluded. So it will gives me the answer for the 0th column or 0th row and the first row. Now if I trigger this, you can see 1, 2, 3, 4, 5, 6. Right? Now let's combine column with that as well. Let's say I need the answer from I need the answer from this 0th row, the first row, okay, as well as I need this 2, 5, 3, 6. Basically, I need answer as 2, 5, 3, 6. How can I do that? Let's take a look. I will type again new array. So this 2, 5, 3, 6, these are under which rows? That is 0th row and the first row. So I will type 0 colon 2, 0 colon 2, comma. Now I have to give values for the column. I need this first column and the second column. I don't need this 0th column, right? So I need 0, 1, 2. It means 1 onwards. So I will type 1 onwards, and you can see. Or you can just type 3, let's say, because the last value is excluded. So it means you are picking first and the second column. So first and the second column. But we all know that if you don't pass the value after this sign, it means it will automatically pick up to the end. So super duper useful. If you're still not able to understand, it may looks confusing. Let's take a look. Let's see one more example. I want, let's say, all the rows, but I need this first column and the second column. Always remember, this is 0th column. So I'm saying I need first column and the second column, and I need all the rows. So what I will type? All the rows. So I will use this colon, comma. Now data for my columns, I will type 1 onwards, and you can see my answer. Super duper simple. So this is about the 2D arrays that you should understand about. The last feature is the filtering. How to apply the filtering. Okay, now let's take a look. I am creating a new array, numpy.arange between 1 to 11. Okay, so my new array will looks like this: 1, 2, 3, 4 up to 10. Super duper simple. I want only the values which are greater than 5. So let's say y is equal to new array greater than 5. So now if I check the value of y, I can get answer in the form of a boolean. So which makes sense right now if I check the answer over here. So 1, 2, 3, 4, 5, the first 5 values are not greater than 5. That is why it is saying false to me. Makes sense? But I need the answer, the values. So if you pass on this y within this new array, you get your answer 6, 7, 8, 9, 10. But instead of doing this using this first principle, you can simply type new array, then your indexing bracket, which is square bracket, where my new array is greater than 5, and I get my answer in just one single line. Or I don't have to do this 3 steps, just one single line. This is my new array, which is 1 to 10, right? And I'm saying that from this new array, I am giving you a condition on which I want to apply this slicing. That is where my new array is greater than 5, and you get my answer. Okay. Let's start with our last topic, I will take just 1 or 2 more minutes and we are done with this session. Mathematics in case of a numpy. So let's say if I create the linear space, numpy dot linear space, I will get 4 values from 1 to 10. Okay, you all know about y to y, right? So you can see that in numpy as well you can do the addition. In numpy you can do the multiplication. Okay, you can do the power, which is over here I'm using square root. Let's say 1 4 7 10 y to the power 0.5. Okay, um but let's say, so this is my y. Okay, just one more thing, y to the power 0.5, which means like square root of y technically, right? So this 1 2, so this is of this number. Square root of 4 is 2, square root of 7 is this, square root of 10 is this, not of this. Don't get confused. I have to then save it as a variable. Z is equal to y into y, then take the z over there. So yeah, so this is my y. I can apply the square root directly as well. I will type numpy dot square root of y. You can get the answer. Okay, similarly you have the exponential functions available with you, numpy dot exponential of y. You can even take a look at over here about this exponential in detail, what it is talking about. Okay, similarly you have numpy dot logarithmic of y. You get your answer, and you can read about that as well if you want to. Okay, and if you see over here very carefully, it is using star args arguments that we have covered, which means like you can pass on as many values as you want, and that is what we are doing. We know that our y, what is y is technically this array, and I can take this array up to as many values as I want, and then I am passing over here as many values as I want, and the logarithmic function will gives me the answer, because I am using the args, which means I can give on as many parameters. It will not be a problem for me. Okay, so let's wrap it up and summarize what we have covered in this NumPy library, which is used for the mathematical or the numerical computation. That how to create the NumPy arrays using the Python list, combined list. Then we talk about the zeros, ones, a range, linear space. Then in the random we talk about the rand, which is uniform distribution, normal distribution, random integer, followed by the reshape, shape, maximum, minimum. Then we covered about the indexing and selection in case of a single and the 2D arrays. Then how to apply the filtering, and then in the end we talk about the mathematics, where we covered about the square root, exponential and logarithmic. So I hope you all enjoyed this, and I will see you in the next one.